question 1, students are asked to consider a particle exhibiting simple harmonic motion, and the acceleration is given by a equals negative 2.95 times x, where x is the displacement from the origin. Now we know that the period of motion, which we can denote by capital T, is given by 2 pi on n. So the idea here would be to find the value of n and then calculate the period as 2 pi divided by that value of n. Okay, so let's look at an approach which could be used more widely and helps to preserve accuracy on the TI-Nspire. What we're going to do is we're going to take n and we're going to assign it by pressing Control and then symbols template, that's the assign command, :equals. We're going to assign it to be a solution to an equation. And the command that we would like to now find is the numerical solve command. So what we'll do is we'll press menu, then we will press 3 for algebra, 1 or enter for numerical solve. And what we will solve is we will solve the equation n squared equals 2.95, and we want to solve that for n, so comma n, so it's comma the independent variable. Then press navigation pad to the right to come out of that closing bracket, and we want to insert the condition that n has to be greater than 0. And the way to do that is if we press Control and then equals, and then we go navigation pad to the left to highlight the with or the given command or symbol, press enter, and we say we want to solve that equation given the fact that n is positive or n is greater than 0. And so type in there, press enter, and we get a value of n to be 1.715, etc., etc. Now all we need to do is we just need to calculate 2 pi divided by n. So we can press Control divided by to access the fraction template. Then for the numerator, 2 times, and then press the pi button. Press enter to insert pi. Down to the denominator box, and all we need to do now is enter n. You can tell it's bold and non-italicized, so n is representing a value, and in this case it's representing the 1.71, etc. Press enter, and we get a decimal answer of 3.658, etc. What we can also do is we can take an answer or a number like that and use the round command to round it to a certain number of decimal places. So what we do here is we press menu, then we select number by pressing number 2, then number tools number 8, and then 1 or enter for round. What we can now do is go up, use the navigation pad up to highlight our last output, press enter, and then we get a full decimalized answer there. And if we want that rounded to 2 decimal places, insert a comma and then enter 2, press enter, and so we get 3.66. And so the period of motion for this particle is 3.66 seconds, correct to 2 decimal places, and so the answer is alternative D. In question 2, the standard deviation for scores of 1,000 students completing an entry test at a certain university is given as 13. There's a researcher who takes repeated samples of the test results, and each sample has a sample size of 40, so in other words, n equals 40, and the researcher calculates the mean score for each sample. What we wish to find here is the standard deviation of the distribution of the sample mean scores. So this is quite straightforward use of TI-Nspire. The standard deviation of the distribution of the sample mean scores is simply given by that original standard deviation divided by the square root of n. So all we need to do here is press Control divided by, and that allows us to use the fraction template. In the numerator, we enter 13, and then down into the denominator box or template. And in there, we will insert the square root of 40. So if we press Control, x squared, then enter 40, and then press Enter. Now, notice that we get an exact answer here. To get an approximate answer, we press Control, Enter. And if we want that rounded to 2 decimal places, what we can do is we can press Menu. We can select number by pressing 2, then number 8 to select number tools, and then number 1 or enter for round. Then use the navigation pad to go up and highlight the last output. Press enter. We get a full decimal answer there. And if we want that rounded to 2 decimal places, all we need to do is insert a comma and then the 2 denoting the number of decimal places. Press enter. And so we get 2.06. And so the standard deviation is 2.06 correct to 2 decimal places. And here, the correct answer is therefore alternative B. Question 3, we're given a quadratic equation, z squared minus pz minus q equals 0, and we're told that 2i is a root of that quadratic equation. Now, by the conjugate root theorem, negative 2i is also a root of that quadratic equation. So without the use of a calculator, what we could do is we could expand z minus 2i and z plus 2i to form z squared plus 4, and then compare the coefficients of z squared plus 4 to z squared minus pz minus q. Note also that p and q are elements of the reals, and if you make that comparison, you can see quite clearly that p equals 0 and q equals negative 4. Another non-calculator approach is to use the sum and product of roots. And by that, we could say, okay, by looking at the sum, p is going to be 2i plus negative 2i, which is 0. And q is going to be negative multiplied by 2i multiplied by negative 2i. The product of those gives you 4i squared. I squared is negative 1, so q therefore equals negative 4. And once again, we get p equals 0 and q equals negative 4, which corresponds to alternative C. But what I would like to show you is an approach with Nspire, which could also be used in a short answer situation where working needs to be shown. So this is an approach that can be used more widely, and it's a very useful approach. So what we're going to do is we're going to assign f of z to be that quadratic. So what we do is we press F and open bracket, Z, close bracket. The assign command is accessed by pressing Control symbols template. We press Z, x squared button, minus p times z. Make sure you use that multiplication sign. We want this to be known as p times z and not variable pz, which consists of more than one character, minus q. And so we press enter. And what we've done now is we've assigned f of z to be that quadratic. Now what we're going to do is we're going to form two equations and solve them simultaneously. So the command that we're after is the solve system of linear equations command. So let's find that and let's fill in the template. So let's press menu. Then we're going to press 3 to select algebra, and number 2 for solve system of linear equations. A dialog box appears, and our number of equations, we've got 2 bits of information, 2 unknowns, so we want 2 equations. We press tab. We don't want x and y as variables here. We want p and q, so p, q there. Press tab to highlight OK, and then press enter. And our solve system of linear equations template is now pasted onto the screen. So what we're going to do now is let's enter the 2 equations. So in the top box, we're going to enter f of 2i equals 0. So f, open bracket, 2, press the pi button to access I, go across 1, that's highlighted, so press enter, come out of the bracket, and we want that equals 0. So our first equation is f of 2i equals 0, and that comes from the fact that 2i is a root of this equation. Navigation pad down, and in our second place for our second equation, we type in f, then open bracket, then use the negation key for the negative sign, negative 2, press the pi button, scroll across to highlight complex number I, press enter, use the navigation pad to the right to come out of that rightmost bracket, set that equal to 0. So we've got our 2 equations. All we need to do now is press enter, and the output there is in the form of a list, and you see the elements of the list there are 0, -4. Now compare that to the elements in the list inside the input p, q, 0, 4. The way to interpret this is therefore p is equal to 0 and q is equal to -4. And so that's a nice way for finding unknown coefficients given roots to a quadratic equation. And as we have confirmed now using 3 methods, p equals 0, q equals -4, and the answer is alternative C. In question 4, we're given a position vector as a function of time, and the position vector is r equals cos ti minus 2 sine tj, where t is greater than or equal to 0. We have 4 alternatives, and the idea is to determine the curve which best represents the path of the particle. Now, without a calculator, we could specify the parametric equations as x equals cos t and y on -2 equals sine t. We could then take those equations, square both of them and add them together, and exploit the identity that cos squared t plus sine squared t equals 1. So if we did that, squaring equation 1 and squaring equation 2 and adding them together, the left-hand side becomes x squared plus y squared on 4. The right-hand side becomes cos squared t plus sine squared t, which we know is equal to 1. So the equation that we're after is x squared plus y squared on 4 equals 1. And this is the Cartesian equation of an ellipse which is centered at the origin, which with x-axis intercepts plus or minus 1, 0, and y-axis intercepts 0, plus or minus 2. This is the curve that represents the path of the particle, and looking at each of the alternatives, alternative D satisfies that, and so alternative D is correct. Now, Looking more widely at if this question or its ilk was a short answer question, what we're going to do is confirm our result by finding the path and looking at it from a graphical point of view. So at the moment, I have a graph application open, and as you can tell from the entry line, we're in function mode. But what we want to be in is we want to be in parametric graphing mode. So let's make that change. Press menu, then select graph entry edit by pressing number 3, and then select parametric, pressing number 4. And our entry line has now changed, and we have the opportunity now to input parametric equations. So for x1 of t, what we're going to do is we're going to insert cos t. So if we press trig, scroll across to highlight cos, press enter, t, and then come down to y1 of t. So this basically is going to mirror the original position vector. We're going to insert the negative sign using the negation key. 2 times, press trig again. Sign is already highlighted, so press enter, and then t. Now below, it's saying that here t belongs between 0 and 2 pi, and the step is a fraction of pi. In this instance, as a decimal, it's 0.13. So that should suffice. So if we press enter and moving the label away, we see that we have what appears to be an ellipse. But let's look at this a little bit more closely by changing the appearance of the graph screen. And by doing this, we're going to press menu, then we're going to select window zoom by pressing number 4. And because our parametric equations are trig equations, we're going to apply the zoom trig command, which is accessed by pressing number 8. And that gives us a good perspective here and gives us a good clear picture of the path of this particle. And you can see from those tick marks there that the x-axis intercepts are at 1, 0, negative 1, 0, and the y-axis intercepts are at 0, negative 2, and 0, 2. So that confirms our mathematics, and it confirms that the correct answer when you look at the 4 alternatives is alternative D. In question 5, we're told that a plane contains the origin and 2 points, 1, 2, 3, and 3, 2, 1. They're the coordinates. We want to find a vector normal to the plane. So visualize this situation. We have 2 coplanar vectors, which are given by I plus 2j plus 3k and 3i plus 2j plus k. And if we want to find a vector which is normal to the plane, and we know those 2 coplanar vectors, then what we want to do is we want to use the cross product on those 2 vectors, and that will give us a vector normal to the plane. So it can be done quite readily by hand, but I think it is slightly more efficient using Nspire. So what we're going to do is we're going to press menu. We want to find the cross product command. So we press menu. Then we want to select matrix and vector by pressing number 7. Then what we need to do is we need to scroll down until we find cross product. And we've found it there using an arrow key. Now, the syntax is we want to insert our first vector then a comma, and then insert our second vector. And we're going to use a column matrix format here. So what we're going to do is we're going to press the catalog button, and the icon there is that open book icon, gives us access to the catalog. And what we want to select here is the M by N matrix template, which is there. And what we're going to do is we're going to complete the template, and we want the number of rows to be 3 and the number of columns to be 1. So with that template highlighted, we press enter, and we're prompted to create a matrix. And as I said, we want the number of rows to be 3. So we press tab, and then we can use our arrow keys to change the number of columns from 3 back to 1, and then press tab to highlight OK, and press enter. And here we have our matrix template ready to fill in the entries. So our first vector is I plus 2j plus 3k. So it's a matter of 1, navigation pad down, enter 2, navigation pad down, enter 3. Then navigation pad to the right to come out of that vector. The syntax requires us to separate the two vectors with a comma, so we press comma, and then we repeat the same process to paste the second vector into the input. So let's do that. Press the catalog button, then select the M by N matrix template, press enter. Number of rows is 3, press tab. Decrease the number of columns using the navigation pad down to 1. Press tab to highlight OK, and then press enter. And this time we want to enter 3i plus 2j plus k. So 3, navigation pad down, 2, navigation pad down, 1. Then press enter. And so a vector normal to the plane is negative 4i plus 8j minus 4k. Now, if you look at the 4 alternatives, the answer we've obtained here is not one of the 4 alternatives. But there's nothing much to worry about, because if you look at alternative A and you take our answer and multiply it by -1, which is a vector acting in the opposite direction, you get a vector which is normal to the plane. So if we multiply by -1, we get 4i minus 8j plus 4k, and we have found a vector normal to the plane, and it is the vector that is in answer A, and so the correct answer is alternative A. In question 6, the diagram shows us 2 coplanar forces of magnitude 12 newtons and 10 newtons, and they're acting on an object as is shown. What we're going to do first of all is we're going to say, let's have vector F denoting the resultant force. Then what we're going to do is we're going to resolve that force into components. And then what we're going to do is we're going to determine the magnitude of that resulting force that is acting on the object. So this approach that I'm showing you here also will be a good approach in a short response type question. So we're probably going to take a little bit longer than what would be required for a multiple choice question, but I think it is worthwhile showing you this approach. What we're going to do is we're going to say, okay, our resultant force, vector F, it's the sum of force F1 and force F2. And looking at the diagram, F1 we can write as 10 cos 22 degrees I minus sine 22 degrees J, and we can write F2 as negative 12J. So what we're going to do on Nspire is we're going to assign F1 and F2 to be those vectors. So press F1, then control symbols template to access the assign command. Then what we're going to do is we're going to press the catalog button. And this time we are going to select the 2x1 matrix template. With that selected or highlighted, press enter. Now what we're going to do is we're going to enter the I component of F1, vector F1. So it is 10 multiplied by cos, so press trig, scroll across to highlight cos, press enter. Now notice that here I'm in radian mode, and the angles are specified in degrees. So what we can do is we can enter 22, then we can press the pi button, go down to highlight the degree symbol and press enter. And what that does is it overrides or overwrites the mode of the page here, which is in radians. So that will be recognized as 22 degrees. And similarly, J component, notice that we need a negative sign, so we use the negation key, negative 10 multiplied by, press trig, paste sign, 22, and again, we'll go in to the pi button, highlight the degrees symbol again, and press enter, and press enter. And don't worry too much for the moment that you get that exact answer, which can look a little bit puzzling. Everything's okay. What we're going to do now is we're going to do the same and assign F2 to be negative 12J. So type in F2, then control symbols template, press the catalog button, then paste the 2x1 matrix template into the calculator application. 0, down with the navigation pad, negation key, negative 12, press enter. So we've got F1 and F2 have been assigned. Now, to calculate the magnitude of F, magnitude of F is basically equal to the square root of 10 cos 22 degrees squared plus 10 sine 22 degrees plus 12 all squared. Now, there is a command on Nspire which enables us to work out the magnitude of a vector, and it's called the norm command. The way to access this, by pressing menu, then select matrix and vector by pressing 7, then select norms by pressing 7, and then select norm. Norm basically is your command for working out the magnitude of a vector. So 1 or enter. Now with F1 and F2 assigned, we can press the var key, var being short for variable. We can paste F1 into the calculator application, plus, and then hit var again, short for variable. Highlight F2, press enter, and then press enter. And actually, what might be a better idea is to press Control Enter. And by pressing Control Enter, what we'll get is we'll get a decimal answer. Notice above Enter there's an approximately equal sign. So Control Enter works quite nicely there. And we can use the round command if you wanted to round this answer to 2 decimal places. You can see that it's 18.27 newtons, correct 2 decimal places. But just for the sake of completeness, if you press Menu and then select Number by pressing 2, and then Number Tools, press 8, and then 1 or Enter for round, you can go up and highlight the last output, press Enter, then insert a comma and 2, which denotes the number of decimal places you would like your answer expressed to, and you get 18.27. And so therefore, the magnitude of the resulting force acting on this object, correct to 2 decimal places, is 18.27 newtons, and that corresponds to alternative D. So D is the correct answer. In question 7, we're given a matrix N. It's a 4x4 matrix, and it represents the results for a competition involving 4 teams. You can see from the elements in the matrix that the elements are either 0 or 1. 0 corresponds to a loss, and 1 corresponds to a win. As mentioned in the question there's a very helpful key that illustrates that if you have a look at the first row of the matrix, you can judge there that Team P lost to Q because there's a 0, but 1 against Team R and 1 against Team S, and they're denoted by elements 1 in that row 1. We're given a ranking model, and the ranking model is given by n plus 0.5 n squared. So first part of this question requires us to form the matrix n plus 0.5 n squared, and then that should help us to determine the order in which the teams were placed first, second, and third. So let's first of all generate this matrix n plus 0.5 n squared. Okay. First of all, we're going to assign n, so Control Symbols Template. We're going to assign n to be that 4x4 matrix. So we're going to press the Catalog button, and we want to select the m by n matrix template. Press Enter. And what we want to do is we want to create a matrix which has 4 rows and 4 columns. So if we go arrow up, we've now got 4 rows. Press Tab, number of columns, arrow up. We've got 4 columns. Press Tab to highlight OK and press Enter. Now what we need to do is we need to enter this matrix. So we've got 0, 0, 1, 1, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, and press Enter. Now what we want to do is we want to form the matrix expression that determines, in this instance, the ranking model. So with n assigned as that matrix, all we need to do is we just need to say, well, okay, we're going to enter n. Notice that it's bold and non-italicized, which is a good sign, plus 0.5 times n raised to the power of 2. So press the x squared button and press Enter. And this is now our ranking model. And what we do to analyze this ranking model is we look at the sum of the elements of each row. Now, the first row corresponds to Team P, then Q, then R, and then S. And what we do is by adding the elements of each row, we can see that the rankings for P sum to 3.5. For Q, it's 2. For R, it's 1.5. And for S, it's 3. So putting those into rankings, P has 3.5, so that's the team that's placed first. S has 3, and so it's placed second. And Q has 2, and it's placed third. So the correct answer is A. What you can also do is TI-Nspire will allow you to sum columns. And so we could form the transpose of this matrix and then look at the sum of the columns. So let's first of all get a transpose for this matrix. So if I press arrow up to highlight that matrix and then press enter, then press menu, then 7 for matrix and vector, 2 for transpose, and press enter. There's our transpose matrix. Rows become columns, columns become rows. Then what we can do is if we press menu, select statistics, then number 3 for list math, and number 5 for sum of elements, then go up and grab that transpose matrix, press enter and enter, and that gives you a display of those ranking points. So P 3.5 ranked first, S 3 points, 3 ranking points, ranked second, and Q 2 ranking points, ranked third. It's easier, of course, to just look at the original matrix and sum the rows. But if the arithmetic was such that it was difficult to perform that arithmetic mentally, then using this transpose matrix approach that I've just shown you will help enormously, because you're allowing the Nspire to perform the numerical calculations for you. So the answer to this question is alternative A. In question 8, we're given a function inverse tan of 2x, and we're asked to calculate f dashed of 3. So what we need to do is we need to find the numerical derivative at a point command. So let's do that by pressing menu. Then we're going to select calculus by pressing number 4. And the top one there is number 1, numerical derivative at a point. So we'll press enter. And the numerical derivative at a point dialog box appears on the screen. The variable we want is x, so we don't need to alter that field. Press tab. The value is we want the gradient at x equals 3. So we'll put in 3 as our value. And we're looking at a first derivative, so we don't need to change that field. So we press tab to highlight OK, and then press enter. Now what we need to do is we need to enter the function. All right, so we've got our template ready to go, and it's just a matter now of entering the inverse tan or arctan of 2x. So we press the trig button, and then if we arrow down and across to highlight inverse tan, and then press enter. Inside the argument there, inside the bracket, we'll put in 2 times x and press enter. Notice there that we get a fraction. Now, the 4 alternatives are all decimals. So what we can do now is we can press Control Enter, and it gives us the value for f dashed of 3 as a decimal. Now, correct to 2 decimal places, f dashed of 3 is 0.05. But just in case, if you wanted to round that to 2 decimal places, it's a matter of saying, well, okay, press Menu, select Number by pressing 2, select Number Tools by pressing 8, 1 or Enter for round, go up to highlight the last output, press a comma, looking at 2 decimal places, so specify that as 2, press enter, and it's 0.05. So f dashed of 3 equals 0.05, correct to 2 decimal places, and looking at the 4 alternatives, that corresponds to answer A. So alternative A is the correct answer to question 8. In question 9, the time in minutes between arrival of customers at a shop follows that exponential distribution with that probability density function. Notice here that random variable capital X representing time, time is in minutes. And if we look at what we're asked to find here, it says that a customer arrives at the shop, and then we're asked to find the probability that the next customer arrives within 30 to 60 seconds of that customer. So we've got to use unit conversions here. Our definite integral needs to be using limits involving minutes rather than seconds. So we need to be very clear that 30 seconds corresponds to 0.5 minutes and that 60 seconds corresponds to 1 minute. TI-Nspire has a lovely shortcut which enables us to access the integral template. We press Shift and then plus. We've pasted onto the screen there is the integral template. Now, our lower limit, we want it to be 0.5 minutes, which corresponds to 30 seconds. Navigation pad up, our upper limit, we want to enter there 1 for 1 minute, which corresponds to 60 seconds. Navigation pad to the right, now we're going to enter 0.12 multiplied by, now press E to the X button and don't press the letter E button, don't press that one. So that's telling us that we've got the exponential function. Now use the negation key, negative, 0.12 times X, and then navigation pad 1 to the right, 1 again, press X, and then press enter, and we get 0.0548, etc., etc. So that's the probability of a customer arriving within 30 to 60 seconds. Notice that if you look at the alternatives in the question, they're denoted or expressed as percentages correct to the nearest percent. So in this instance, the probability is 5% correct to the nearest percent, and that corresponds to answer B. So alternative B is the correct answer for question 9. In question 10, we're given 4 Argand diagrams, and we're asked to determine which one best represents the solutions to the equation z to the power of 4 equals 16 cis 2 pi on 3. Now, from the fundamental theorem of algebra, we expect a maximum of 4 solutions. And so each of those alternatives, there are 4 dots that each represent a solution. And what we can do here is we can let Z equal r cis theta and substitute that into the equation. And if we do that, we can say that r to the power of 4 cis 4 theta equals 16 cis 2 pi on 3. By equating the moduli, r to the power of 4 equals 16, and therefore r is equal to 2. Have a look at those four alternatives. We can now therefore disregard alternative A, and we can disregard alternative B. So our two alternatives are either C or D. So what we're going to do is, with Nspire, we can determine the solutions to this equation directly. And we're going to use a command called complex roots of polynomial. So let's show you where that is, and let's show you the required syntax. So we press menu and we select algebra by pressing number 3. Select polynomial tools by pressing number 3. Select complex roots of polynomial by pressing number 3. Now, the assumption by which this command works is that anything we enter is set equal to 0. So what we need to enter is z to the 4th minus 16 e to the 2 pi I on 3. And the reason why we enter e to the 2 pi I on 3 is because Nspire does not recognize cis 2 pi on 3. So we have to use what's called Euler form or exponential form. So let's enter this. So start off with z, use the explanation key, 4, arrow to the right, and minus 16 multiplied by, use the e to the x key, not letter e, control divided by for the fraction template, press 2 times, press the pi button, press enter to paste pi onto the screen, multiplied by, press pi again, scroll to the right to highlight complex number I, then navigation pad down in the denominator box there, enter 3, then navigation pad to the right once, and then to the right again, and then now the cursor is down level with Z and with 16. We need to say which variable we want to find the roots for, so it's Z, so we comma, Z, press enter, and there we have our 4 roots. And notice that they're all in Cartesian form, and they're in the form of a list. What would be more useful to us is if we were to take those 4 roots and express them in polar form. So let's do that. We're going to do now, so we're going to press menu. Then we're going to select number by pressing number 2. We're then going to select complex number tools by pressing number 9. And then we're going to select convert to polar number 6. You can also obtain that command from the catalog as well by scrolling down into the catalog section where the commands start with P. So it's saying, that input is saying, let's take that list of roots which are in Cartesian form, let's specify them in polar form. And here we have our 4 roots in polar form. And moving in an anti-clockwise manner around the Argand plane. The first one is at 2 e to the pi I on 6. The second one is at 2 e to the 2 pi I on 3. The third one is at 2e to the negative 5 pi I on 6. And the fourth one is at 2e to the negative pi I on 3. Okay? And when you look at either alternative C or alternative D, what you'll find is that those four solutions expressed in polar form match up with the solutions denoted in option C, and so alternative C is the correct answer.